Good evening, everyone. My name is Gavin. Welcome to the first official episode of my MCAT series, where I pretty much just go through my journey of trying to master material for the MCAT. To preface, I am not a teacher, so do not substitute this for your MCAT prep. Pure entertainment, and honestly, just to see my progress from a graphical scale. Today I did the U World passages. I did 30 questions of the chemistry and physics passage. I just created my own test. I did untimed and tutored so that I can see each question I got correct and incorrect as I went through it, which I would not recommend for a future, but I'm just getting the hang of it right now. And I wanted to go through the topics that I had a clear content gap in or lack of understanding thereof. And it's not too many, but this is the point really of my series is to go through things that I did not quite understand, kind of practicing the Feynman technique of being able to teach it to yourself. So let's get started. Share my screen. So what I did was I pretty much got out my iPad and I just wrote down pretty much the main topics that I missed. First one here is measurements in chemical composition, kind of just the topic on UWorld, but density, which I know sounds pretty silly, but as we know, guys, density is mass over volume. But the main thing that they can test you on is the relationships of density. So one way that they can test you on this is to imagine a container of a liquid and then imagine a glass bubble that has the same liquid inside of it to where the densities of these two liquids match. And then they will ask you what will happen if a property changes. So one relationship that you need to be aware of is that as you increase temperature, volume will also increase. It is a linear relationship. Um, so what I kind of missed on in my mind of just quit thinking was that if you increase temperature, volume will increase, thus decreasing density because it's a greater fraction, smaller whole number. And thus, if temperature increases, volume increases, decreasing density, which will make this glass bubble do what? Well, in the problem that I did, the temperature was actually decreasing, thus the entire liquid um, increased, and thus the glass bubble will rise because the density in the glass bubble was now lower than the density in the entire container. So that was one thing that I kind of missed on, but the main thing was just forgetting to apply it to the density equation there, which is very common in physics, is to be able to use SI units in various places. Um, Next topic, which this is still physics, is relative velocity. And how I like to think of it now is that velocity in regards to relative velocity is the velocity of an object that's measured from another object. So you can have your minimum and maximum. So relative velocity to objects can be moving in the same direction or in opposite directions. And in my example, one object was pretty much catching up to the other object, and they wanted to have you measure the relative speed, which is a core relationship. It's the magnitude of the velocity itself. And to measure the minimum relative speed, you're just going to take the difference between the speeds of the two objects. So for me, it was like 25 meters per second against 5 meters per second. So to find the minimum, you would just subtract those two, it's 20. The maximum relative speed is you're trying to take the sum of those two values. So it'd be 25, 5, 30, right? So then the concept was, okay, well, what's the difference between those? Kind of just a quick, another way to make you think through those things. So to be honest, I was never really aware of relative velocity, I guess, as a concrete term. It was kind of just something I just thought was velocity. So that was on me. But yeah, not too bad of a concept. But to remember, one thing is that speed is a scalar value and velocity is a vector. So it's direction and speed, or magnitude and direction. Next concept here, still sticking with physics. As you can guys tell, it's my weakest point. I forgot pretty much an entire kinematics equation. So uniform accelerated motion, it's deemed distance equals initial velocity times time plus half at squared, a acceleration. And one thing I failed to do was to rearrange this equation, let alone remember it, to solve various problems. I'm trying to remember exactly what the question was, but it was measuring the uniform acceleration. And right off the bat, you should be able to quote this equation to yourself. I failed to do that. Um, one thing that I wanted to make sure that I remind of myself, I guess talking to y'all, remind of myself is that they can ask for uniform motion of whatever, right? But are they asking for the distance or initial velocity or acceleration in that case? Because I had to isolate the A to find it. Um, Also, if the initial velocity is not given, then you need to make sure that it's zero and that you're not trying to find some random value for it. So, uh, if y'all have trouble with that too, I don't know, but I sure did. So moving on, I think that's the last. Actually, there's a couple more, one more physics one, but the next one, yes, should be the last one, is the Doppler effect. Easiest way that I like to think of it is that the Doppler effect is the change in frequency related to motion between an observer and a source, right? So when an observer and a source both have changing frequencies related to motion, then that concept in and of itself is the Doppler effect, which can have many different applications of problems. My problem was tested on periods, which I honestly just knew the term of it. I didn't really know what it really meant. Um, but period T equals 1 over frequency. And if frequency is the amount of oscillations per time, then frequency is the amount of time it takes to complete one oscillation or a completion of something. Um, so one thing to note is that the period of a wave changes based on motion, and that when a source and observer move toward each other, then the wave period is decreased. This is kind of a hard relationship for me to really get a grasp of, to be honest with y'all. I really took a long time staring at this problem because I was kind of a little lost. Um, but one thing to note here is that when the two objects are moving towards each other, you can just think of it as because the um, time it takes, or the time between the crests, because they decrease, then that means that the observer's period will be less than the source's period. So TO. Um, and because of that, uh, waves hit the wall with a lower period, deems this relationship here. And then that period going back is the wave reflected from the wall. To be honest, I really feel like I might be better off just memorizing this relationship and that's it. Trying to teach it right now, so it's a little vague, but hopefully I can get better at that. Next topic, to be honest, I did not know. I've never even heard of this. Omega numbering of fatty acids. I guess my Orgo teacher just flew past this one, and also I don't remember seeing it in the Kaplan books. But Omega deems this not really a W, but like a little swivel like that. Uh, Number of fatty acids. Um, I'm really only writing this down just in case if it pops up again, but to locate the carbon double bond in a chain of a fatty acid, you just find the double bond here. So you have one, two, three, four, five, six, seven, eight carbons in this link. And then the first alkene is at carbon 3, and the second one is at carbon 7. We don't number from this direction here because this carboxylic acid, so it has priority. Um, so in order to deem the omegas of the fatty acids, you just take the total number of carbons minus the first carbon in the alkene chain, and do the same thing. Um, and that's really it right there. I just realized this should say W5 and that should W1. So I don't know how I just did that, but whatever. Um, sure. I don't know. Um, and then the last thing that I wanted to talk about and I didn't get this one wrong, but this is the lab that I work in, so I think this is very interesting. And also, it's a very important technique in chemistry, specifically organic chemistry, and really inorganic and also just analytical chemistry in general. This is a very important technique to measure the molecular weight of a molecule. It's the spectrometry. And really what uh, that means is to use the advantage of magnets and ionization tools in order to find out the molecular weight of a molecule. So that's right, the big goal of this instrument. And what you do is also found a picture online just to help visualize it. I'll kind of bounce back and forth. First step in it is when you load the sample into the instrument that the sample is ionized. So which means that it can break apart into fragments. That's kind of deemed the first part right here. This electron beam, whenever it ionizes it, it kind of breaks apart the electrons from the um, molecule itself to where the electrons kind of come off and everything. And what you get are these like little fragments deemed here. So it can break apart into the fragments. And then these ions are accelerated toward a magnet. So you can kind of see this right here, the big old magnet right there. And then the ions are deflected according to their mass. So this deflection right here from that magnetic field, ions of different masses are going to deflect at different rates or at different strengths. And then the fragmented ions are detected. And when they are detected right here, that is kind of forged into a graph. And this is the main graph that you need to know. The y-axis is the ion mass abundance or just mass abundance. Then the x-axis is the mass ion ratio. So that's mass abundance, mass ion ratio, or mass charge ratio is the main graph that you need to be able to pretty much just know represents the spectrometry um, technique. And then these peats here are the ionized fragments of the sample, right? So um, as you're reading the graph, you know that the higher peats have higher mass abundance, and then these peats are used to identify the molecular weight of molecules. And from that, this might be out of scope, I'm not sure, but in my lab, we use this data to pretty much determine what known molecules based off of their known weights and compounds, what known molecules are in a sample, right? So we'll compare these values to hundreds of different amino acids and metabolites and lipidites and everything. But the main core of this instrument is pretty much what you see right here. These steps, I don't know if they have to be known, but I just have them there. And then the graph is the big one. This was the U-World question that I was tested on. And another one too, but I couldn't really find it. But yeah, kind of the big picture there. Uh, so yeah, so that is the main. Oh, all right. So that is the main thing for me today. A lot of physics and chemistry because that's what I tested on today. One thing I'm noticing is that constant review is definitely vital and helpful, but your ability to understand what the question is asking and your ability to triage information is what will simply determine your percentile. So, um, thank you guys for watching. Hope to be back here uploaded tomorrow, but we'll see. But thank you all and good night.